thinking? Can you guys see the screen?
Yes.
Okay.
Yes.
So basically what we want to do right now, guys, for this session is that I want to review what you guys have done for the entire week, right, with Mrs. Katsim. And then I want to go ahead and do the activities with you guys. I know that today you guys rushed through, those of you that were online, you rushed through the package. And I just want to verify that all of you understood what was taught this week and get a clear idea of what um, you are supposed to do in the package. All right. So basically, what you guys talked about this week was number properties and number laws. So some of the things that you talked about are referred to as properties because they are things that numbers do or we do with numbers, and that does not change. And then you talked about number laws, which are rules, which are things that I need to follow when I look at a problem and I solve it. All right. So now we're gonna start with the number properties. The first number property that you guys looked at was the identity property. Identity property for addition and identity property for multiplication. Most of the rules that we're going to look at and most of the properties deal with addition and multiplication. Those are the ones that we want to concentrate on. So when we talk about identity property is, for example, take a look at yourself. All right, I take a look at me. I am Miss Mai. I am the math teacher. My identity is Miss Mai. Nobody can change my identity, right? I can't be Miss Mai today and then tomorrow I'm Miss Cal or the next day I am Miss Pat, and I change who I am every day. So now the identity property talks about when I do something to a number, then whatever answer I get is has to be that same number. Right? So that is the identity. We have a 4, my answer has to be 4. We have 1, my answer has to be 1. So now the identity property for addition says if I have a number and I want my answer to be that same number, the only way that I can get that is by adding 0. Because 4 plus 0 gives me 4. 0 plus 3 gives me 3. Negative 4 plus 0 gives me negative 4. And 0 plus negative 3 gives me negative 3. So the identity property for addition. So when you hear me say, what is the identity property for the addition? It is when I take a number, I add 0, and it gives me back that same number. Everybody understood that one?
Yes.
Okay, good.
Yes, miss.
So now this is for addition, when we are adding. Now let's move on to multiplying. What is the identity property for multiplying? So when you hear identity, then you're supposed to say, okay, I have one number. My answer has to be that same number. The only way the identity property is going to change is if I'm talking about addition or if I'm talking about multiplication. So now the identity property for addition talked about me adding 0 because it's plus. So when I talk about identity property for multiplication, I have to multiply. So I have a number, I'm going to multiply, and my answer has to be the exact same number. And the only way that that happens is if I multiply by 1. So 8 times 1 gives me 8. 1 times 9 gives me 9. Negative 8 times 1 gives me negative 8. And 1 times negative 9 gives me negative 9. So when I multiply by 1, I'm getting back the same number. And because I get back the same number, that is the identity property for multiplication. So the identity property for addition is me adding something for me to get back that same number. And in that case, I'm going to add 0 because anything plus 0 gives me back that same thing. And then for multiplication, I need to multiply by something that gives me back that same number. So when I multiply something by 1, it gives me back that same thing. Any questions?
No, miss.
It's clear? Identity property?
Yes, miss.
Very good. So now let's talk about the inverse. So we have the identity for addition and multiplication. Now you want to talk about the inverse for addition and multiplication. So now the inverse. When you hear the word inverse, you want to think about like the opposite, al revés, right? The opposite. So when I talk about the inverse for addition, I think about this zero. Remember, identity talks about zero for addition. So the inverse, we're going to talk about zero as well. So now the inverse for numbers under addition, I need to add two numbers that give me zero. But these two numbers have to be the same thing, have to be the same number, but different signs. So I have an example. If I give you the number 5 and I tell you, give me the inverse of 5, you are gonna say negative 5 because negative 5 is the opposite of 5. If I tell you, give me the inverse for negative 3, you are gonna give me 3 or positive 3. Same thing. So if I say, give me the inverse for negative 3, you are going to tell me positive 3 because they are the opposite. And because they are the opposite, when I add them, they give me 0. So 5 plus negative 5 gives you 0. Negative 3 plus positive 3 gives you 0. Everybody understood? Or do I need to repeat? If I need to repeat, you guys just say so and I will repeat, okay? So it's clear. Can I move on?
Yes, miss. Can you please repeat it?
Can I repeat? Okay. So now here we're talking about inverse. When you talk about inverse, you want to think about the opposite, right? Opposite of what I'm giving you. So if I give you something, you have to give me back the opposite. That is what we want to talk about in inverse. Now, when we talk about inverse for addition, I need to add one number and I'm going to add it to its opposite so that I can get 0. So if I give you 5, you are going to tell me that the opposite is negative 5. If I give you 3, the opposite is negative 3. If I give you 10, the opposite is negative 10. If I give you a negative number, let's say I give you negative 7, then you are going to tell me the opposite is positive 7. If I give you negative 12, you are going to say the opposite is positive 12. So inverse of addition is talking about the opposites of that number. And one number always has to be positive and the other number has to be negative so that they are opposite to each other. And now, because they are opposite to each other, when I go ahead and add them, my answer is going to be 0 because 5 plus negative 5 gives me 0. Negative 3 plus 3 gives me 0. 10 plus negative 10 gives me 0. Negative 12 plus 12 gives me 0. Is it clear now?
Yes,
Yes?
Yes,
miss.
miss. Yes,
Okay.
miss. Oh, yes.
Okay. So
Yes,
now
miss.
we talked about the inverse for addition. Now you want to talk about the inverse for multiplication. So now we want to do the same thing. We want to talk about opposite. For addition, opposites were negative, negative and positive, negative and positive. That was the opposite. If I have a positive, you give me a negative. If I have a negative, you give me a positive. That was for addition, the inverse of addition. Now, when we talk about the inverse for multiplication, I want to talk about the reciprocal. El al revés. If I give you 6, you give me 1 over 6. If I give you 5, you give me 1 over 5. If I give you 7, you give me 1 over 7. Right? And if I do the opposite, if I give you 1 over 8, what is the opposite of 1 over 8?
8 over
8. Or you could say 8 over 1. Both of them are still correct because they mean the same thing. So if I give you 3, the opposite or the inverse is gonna be 1 over 3. If I give you 1 over 10, the inverse is gonna be 10. All right? Now, why is that the inverse? Why is the inverse of 6 1 over 6? Because when I multiply them, they give me 1. When I multiply 6 times 1 over 6, it gives me 1. When I multiply 1 over 5 by 5, which is the inverse, and I multiply that and I solve it, it gives me 1. And the same thing if I were to give you a negative. Now, when I gave you 6 and the inverse is 1 over 6, both of them were positive numbers. So if I give you a negative and I tell you negative 7, the inverse of negative 7 is going to be negative 1 over 7 because it is a negative number that I'm giving you. So if I give you negative 5, the inverse is going to be negative 1 over 5. Did everybody understand?
Yes, Miss. Now, yes, Miss.
Okay, good. So we have talked about 4 things, right? We have talked about the identity for addition. Identity for addition is I give you a number, you add 0, and it gives you back that same number. We talked about identity for multiplication. I give you a number, you times it by 1, and it gives you back that same number. We talked about inverse for addition, and the inverse for addition is one positive number, one negative number. When I add them, they give me 0. And then now we talked about inverse for multiplication. I give you a number, you give me the reciprocal, and that equals to 1 when I multiply them. So we talked about 4 things. Are those 4 things clear to everyone? Yes, are they clear before I move on?
Yes, Miss.
Yes,
Yes,
miss.
Miss.
Okay.
Yes, Miss.
Yes, miss.
So now these ones that I'm going to talk about are very easy. Now Miss Katsim did not talk about these, but these were a part of your assignment. And this is what and I have to cover them so that you are able to complete the assignment completely or correctly. If you go in Google Classroom or if you have a printed package, then I have these rules there already. If you guys go to Google Classroom, those of you that are online, and you go to week 6 content, it's supposed to be there posted. All right. And then those of you that have package, this is in your package, the same exact examples that I'm giving here in the PowerPoint. So now multiplying a number by 0. If I multiply a number by 0, what is going to be my answer?
0.
And does that happen all the time?
Only when you multiply a number by 0, it will always give you 0, Miss.
Very good. It will always give me 0. If I have 8 times 0, that's going to be 0. If I have 0 times 7, that's going to be 0. If I have 1,000 times 0, that is going to be 0. And that is the property. That's all about the property. When I multiply by 0, I always, and I stress on the word always, get 0. Nothing, no other answer can be provided. Only 0. A number times 0 will give me 0. All right? Now, division by 0 is a little bit more different. Using the word different. Because I could have 3 divided by 0 and I could have 0 divided by 3. And let me put that in the chat. 3 divided by 0 and 0 divided by 3. Are those two questions the same thing or are they different questions?
Means I think it's the same because we'll give the same answer.
That is okay. In primary school, that is what they teach you. They teach you the basics, right? They tell you anything that has 0 and division is going to be 0. But we are in high school and we want to know the correct thing that happens when we have 0 and division. So, the two questions that I put in the chat are two different questions that give me two different answers. And I'm going to explain right now. Who can tell me what is that sign that looks like an 8 but slanted, like lying down? What does that symbol represent? Anybody knows? Anybody has an idea of what that symbol is? The one that looks like an 8 lying down? Nobody has any ideas? That symbol is what we refer to as infinity. Who knows what infinity is when we're talking about numbers?
Basically,
Means I think infinity is a number that never ends.
Okay. When we talk about so when we talk about the numbers, I can continue counting and counting and counting and counting, and I will count forever and ever, and I will never finish counting, right? Infinity is used to represent that last number that nobody knows what it is because we can continue counting and counting and counting. So infinity means something that never ends, yes, but we use it to refer to the last number in our list, even though we don't know what that number is. So, why is 3 divided by 0 equal to infinity? And I'm going to explain why. When we talk about division, we're talking about groups, right? So if I have 3 and I'm going to divide 3 by 0, I am going to be taking out groups of what? Groups of how much?
Groups of nothing because it's a 0.
Groups of nothing, groups of 0. Very good. So now, if I have 3, I took a group of 0. How much do I have?
3.
3.
Okay. Still have 3. I took out another group of 0. How much do I have?
Still 3.
And I
You
took out
have
another group of 0. How much do I have?
3.
And I continue with
Same.
another group of 0, another group of 0, another group of 0, and I can do this forever and ever and ever, and I will continue taking out groups of 0. And how much will I end up with?
3.
So this is why 3 divided by 0 gives me infinity. If I have 5 divided by 0, that gives me infinity because there are infinite number of groups of 0 that I can take out and take out and take out and take out and take out, and I will continue taking out, and I can do that for infinity times groups of 0, and I can continue taking out groups of 0. So that's why any number that is divided by 0 will give you infinity. Is that clear?
Yes, miss.
So now let's do the opposite now.
Yes.
What if I have 0 divided by 3?
0 divided by 3.
So when we do the opposite, I have 0 divided by 1, 0 divided by 5, 0 divided by negative 3, and 0 divided by negative 4. And what is the answer for all of those questions?
There,
Zero.
there, zero.
Zero.
And this is why. Because if I have 0, I have nothing. And I want to take out a group of 1. How many groups of 1 can I take out of 0?
Nothing. Zero. Nothing.
0. If I have 0 and I have to take out a group of 5, how many groups will I take out?
What was your question, Miss?
If I have 0 and I want to make a group of 5 out of this 0, how many groups of 5 will I take out?
Zero. Zero.
0. Very good.
Zero means
So when I have 3 divided by 0, that gives me infinity. And when I have 0 divided by 3, that gives me 0. So do you understand that these are two different questions with two different answers?
Yes, Miss.
yes, miss.
Very good. Very good.
Yes, miss.
So now we talked about 6 properties. 6 properties, right? We talked about identity for addition, identity for multiplication, inverse for addition, inverse for multiplication, multiplying by 0, and dividing by 0. 6 properties. Now we want to move on into the number laws. These are laws, like laws of a country. You can't break the laws, you have to follow the laws. So these are things that when you see a question that has this, I need to follow this law, right? So we're going to talk about the 4 laws that are left. The first law is the law of closure, or closed under an operation. That is the name that Mrs. Katsim used. Closed under an operation is the same thing as law of closure. But law of closure is the one that I have in the package. So now the law of closure states the following. A set of numbers is closed under an operation if, when the operation is performed on any 2 members of the set, then the result is a member of that set. Now that was a big long definition to mean something very, very simple, and I'm going to show you guys the example so you understand. This law is saying that how many operations do we have? What are the 4 basic operations that we have? Who can tell me what are these 4?
Addition,
Addition, okay.
and
Subtraction,
multiplication,
Multiplication.
and
multiplication,
division.
and division. Very good. So now, when we talked about close under an operation or law of closure, it has to be 2 of them only. Which 2 have we been talking about in the properties?
Adding and multiplication.
Addition and multiplication. Very good. The law of closure only applies to addition and multiplication. Why? Because if I have 6 plus 5, that gives me 11. The 6 and 5 are what kind of numbers? Remember in the first week when we had classes, we talked about types of numbers. Under what group do these fall under? 6 and 5. Who can tell me? Anybody remembers? What were the types of number that we talked about? We talked about real, rational, irrational, integers, natural, whole. What kind of numbers are 6 and 5? I heard the answer.
Rational,
They're rational, very good. What other type of number?
Real.
They're real numbers, very good. But you want to get to the specific one. What other type of numbers are 6 and 5?
Whole number.
Whole numbers, very good. They're whole numbers. 6 and 5 are whole numbers. What is 11? What kind of number is 11?
A real number.
It's a real number, yes. What kind of other number?
Whole means
A whole number, very good. So 6 is a whole number, 5 is a whole number, 11 is a whole number. All of them are whole numbers. And because all of them are whole numbers, this is the law of closure. This is closed under an operation. Because the rule says I need to add or multiply only those two. The two numbers that I'm adding have to be of the same group, and my answer has to be of the same group. So 6 and 5 are whole numbers. I am adding them, and my answer is a whole number. So that makes it a closed under an operation. And the same thing with the times. 3 and 4 are whole numbers. 12 is a whole number. And because I'm doing multiplication, it is closed under an operation. Any questions?
no miss.
So, what about subtraction and multiplication? Subtraction and multiplication are not closed under an operation because 5 is a whole number, 8 is a whole number, but when I do 5 minus 8, it gives me, what is negative 3? What kind of number is negative 3?
An integer.
An integer, very good. So because two whole numbers give me an integer, this is not closed under an operation. So what are the two operations that can be closed? Which two?
Division and subtraction.
Division and subtraction cannot be closed. So if division and subtraction cannot be closed, which one are the ones
Addition
that?
and addition and multiplication.
Addition and multiplication. Very good. The commutative law. Commutative. Commutative is like, have you heard when they say you are commuting, you are traveling? Commutative is like traveling and changing and moving. So when you think about commutative law, you have numbers that are moving their places, right? They're switching places, they're moving from one place to another. But it doesn't matter where they move or where they go because they give me the same answer. So when you think about commutative, they are moving, they're switching, but they give me the same answer. And commutative is only for addition and multiplication. So for example, 2, 2 plus 3, the 2 plus the 3, I can switch them and I can have 3 plus 2. And doesn't that give you the same answer? Yes.
Yes, miss.
And
Yes,
the same thing with multiplication. 4 times 6. I can switch them and have 6 times 4, and that gives me the same answer. And I could do that for bigger questions, like 2 plus 6 plus 9. I can switch up the 2 and the 6 and the 9 and put them in whatever order, and when I add them, they give me the same answer. And the same thing with multiplication. 2 times 3 times 5, I can have 5 times 3 times 2. I can have 5 times 2 times 3. I can have 3 times 5 times 2. I can have 5 times 2 times 3. And I can switch up the order as many times as I want. But when I multiply it, it will always give me the same answer. Any questions?
no miss. No miss.
No miss.
Okay.
No miss.
Now, this does not work for subtraction and division, right? And I just showed these ones here because it does not work for subtraction and division. So when we're talking about number properties and number laws, only think about addition and multiplication. Those are the only ones that we think about, right? The associative law. When you think about associative, you think of the word associate. You group. You find your best friend and you don't want to lose that best friend. You are associating with somebody. So it's the associative law. The associative law for arithmetic operations deals with grouping numbers. So, associative and commutative are basically the same thing. In the commutative, I can switch up the numbers and they give me the same thing. In associative, I am switching the numbers, but by grouping them. So, how does the grouping work? The grouping works with brackets. So, if I give you the question 3 plus 4 plus 7, that is an addition. But if I want to apply the associative, I'm going to group it. So I'm going to group 3 and 4 and leave the 7 outside. But 3 plus 4 plus 7 is the same thing as if I have 3 plus 4 in brackets and then plus 7. And that is the same thing if I have 3 plus open brackets 4 plus 7. Because when I add these three things, they give me the same answer. And the same thing for multiplication. I have 2 times 4 times 5. If I group the 2 and the 4 and then times the 5, it is the same thing if I group the 4 and the 5 and then times 2. They will all give me the same answer. Any questions?
No,
No,
miss.
miss.
And now the last one is the distributive property. And the distributive property, when you think about it, you want to distribute. Quieres repartir, right? So you're sharing things out, you're distributing. And that is what happens in the distributive law. Now, how do I know the difference between associative and distributive? Commutative and associative can either only have addition or only have multiplication. But the distributive has addition and multiplication together, right? So now how does that look? And we have a question right here. 2 times, open brackets, 4 plus 3. I have the addition inside of the brackets and the multiplication outside of the brackets. But I need to distribute. So I am going to distribute what is on the outside with everything that is on the inside. So I'm going to take the 2 times the 4. And I'm going to take the same 2 and times it by 3. So I have 2 times 4 plus 2 times 3. And then I can solve now. 2 times 4, that gives me 8, and 2 times 3, that gives me 6. And when I take the 8 and I take the 6 and I add them, that gives me 14. And I have used the distributive law to solve this question. Anybody has any questions?
Miss,
Yes.
you always share the multiplication one in the inside one?
Yes, always. So if I would have, let's say in the brackets, inside of the brackets, I have 4 plus 3 plus 5. I would need to share the 2 with the 4, the 2 with the 3, and the 2 with the 5. So I need to share
Okay.
what is on the outside with every single thing on the inside. Yes? Is it clear?
Yes, miss.
Yes, miss.
Yes, miss.
Okay.
Yes,
So
miss.
let me find. I will have to share this screen right here. Okay. Okay, can you guys see the document?
Yes, miss.
Yes,
Yes.
yes, miss.
So now this is the first activity, right? Learning activity, identifying laws. So now this is what you guys are going to be doing. All right? So now it says in instructions, students will write the corresponding number properties or number laws. So we did 6 properties and we did 4 laws. So in all, we have 10 things that we can choose from to write each of our answers. All right. And you are going to write the name in the space that I have provided. In your case, if you have the package, you can write it on the line. If you are writing it in your notebook, you can go ahead, write the sentence, and then write the name at the end. Or if you are creating it online, you can just add the name there. Right? So you guys are free to do it however it's more comfortable for you guys to do it. So now the first one says, number 1, multiplying any number by 0 yields 0. Now, yields is a fancy word to say gives, or the answer is 0. For example, if I get a number and I times it by 0, the answer is going to be 0. What do we call that? What property or law is this one talking about? Which property did we talk about that says when I times something by 0, it gives me 0? What is the name of that property? It's not the identity property. You're thinking along the street, the lines, but we talked about it. It's very, very direct. What are you doing there? What is happening there when I have A times 0 gives me 0? What are you doing there?
It give you
Do you want me to put the 10 things in the chat? Would that be easier for you guys?
Yes,
Yes.
Miss.
So you guys can choose from there? Okay. Give me a few minutes so that I can type all of it. Identity property. Nobody send anything in the chat, right? So I'm just gonna list it right now. So don't send anything right now. Identity property for addition, identity property for multiplication, inverse of a number under addition, inverse of a number under multiplication, multiplication by 0, division by 0. So then these are the 6 properties. And then the laws, you have closed under an operation. You have the commutative law, the associative law, and the distributive law. Yeah, so that is your word bank, right? Basically, that is your word bank. So now if we look at this first question, multiplying any
I
number
think
by
it's multiplication by 0, Miss.
multiplication by 0. Very good. Multiplication by 0. Let me see if I can add a text box. Where can I add a text box here? Mm, okay. So here I'm going to have multiplication by 0. Yes? Okay, next one. When 3 or more numbers are added, the sum is the same regardless of the grouping of the addends. And grouping is the key word here. What is the answer for that?
Associative law.
Sorry, my bad. Yes, it's associative law. Let me fix this real quick. Insert. Let me fix this, guys, right now. 1 second. Insert. Okay. Okay, so we did number 6, right? So let me write the answer for number 6 and then we'll go back to number 2. We said associative law, right? Okay. So let me go back to the Zoom. Okay. So number 2 says adding 0 to any number leaves it unchanged. For example, a plus 0 is a. What would be that one? Yes, Isari, I will be uploading and then I will be sending the video to you guys. So when we add a number to 0 and we get back that same number, what do we say that was?
The identity property, miss?
The identity property for which one? Addition or multiplication? For
For addition,
addition.
miss.
Very good. Very good. For addition. So here I'm going to write identity property for addition. Yes, that will be number 2. Okay, number 3. When two numbers are added, the sum is the same regardless of the other addend. For example, if I have a plus b, that is the same thing as b plus a. What law or property is that?
Inverse of a number under addition.
It's not inverse. Remember, inverse is one positive and one negative.
Miss,
Yes, Kami.
the commutative of addition.
The commutative law of addition. Very good. Now, commutative. Remember commutative? We were talking about it just now, and we said that it doesn't matter the order. If I have 2 plus 3, it is the same thing as 3 plus 5. Then, sorry, 2 plus 3 is the same thing as 3 plus 2. So this is what it is saying when it says a plus b and is equal to b plus a. Right? So let me write commutative law for addition, just to be a little bit more specific. Okay. The additive inverse of a number. Now, when I have a positive number and I want the opposite and I add them, what is that called?
The inverse for additions.
The inverse for addition. Very good. Inverse of a number under addition. Yeah. Okay. Now, this last one. When three or more numbers are multiplied, the product is the same regardless of the order of the multiplicants.
It's not identity of multiplication.
No, identity of multiplication is when we multiply by 1. Remember, identity, I want the same
This is
thing.
the associative.
The associative for
Multiplication.
multiplication. Very good. So I'm going to write this one. Associative for multiplication. Yes. Any questions so far, guys?
No, miss.
So then number 6.
No, miss.
Number 6 is going to be associative law for what? What is that one showing?
Addition, miss.
For addition, miss, for addition.
Addition. Very good for addition. Number 7. The sum of two numbers times a third is equal to the sum of each addend times the third number. So take a look at this one. A number on the outside, I am timesing it by an addition. Which one? The distributive. Very good. Distributive law. The sum of any number and zero is the original number. When I add something to zero, it gives me back the same zero. What is that called? I mean, the same number, sorry.
Identity law, miss.
The identity property for
Addition.
addition. Very good.
If I already did all of that, I have one correct.
Okay, very good, very good. Okay, so let's continue. The multiplicative inverse of a number. So if I give you a number, you give me the reciprocal and we multiply them and it gives you 1. What was that called?
Inverse.
Inverse of a number under what?
Multiplication.
Addition, miss.
Inverse of a number under multiplication. Remember, we are multiplying here. It says multiplying. And then the last one, when two numbers are multiplied together, the product is the same. So if I have 2 times 3, it is the same thing as 3 times 2. What is that called?
Commutative law.
Commutative law or
Multiplication.
multiplication. Very good. So now we have answered these questions right here. The second part is this one where you have to write 10 ways to make a happy school. So, you are going to be using the 10 commandments that I have here. Number 1 says trust God. So, how can you make a rule that sounds like that?
Excuse me, miss.
Yes.
What was the last answer?
Commutative law for multiplication. Yes? Okay. So now the 10 commandments that you're going to write here are 10 rules that you need to write that you think are 10 rules that students or everybody, students, teachers, principal, everybody should follow so that you make a happy school. And those are your own things, your own thing that you want to write there that can work, right? So now this one right here, fill in the blank spaces by following the distributive property. I'm going to fill in the blank spaces. Let me see if I could be able to do this one. Okay. What number comes here in the first one? If I take a look at the example, it gives me 30, 35 times 2, right? But then if I want
So
the
the 60, miss.
okay,
60, miss.
60, very good. Okay, what about the other one? 29 times 6.
20, miss.
20
And the
and
next
9,
one.
miss.
20 and the
And the
other
next
one?
one, 9,
9, very good. This one?
10.
10 and the other one? What would go there?
66.
No, no, no. Here in the second one, if this first one is 10 times 6, what would be the other one? You remember, it's 18.
8.
8, very good. And then now, here I would have, what is 10 times 6?
16.
60, very good, 60. And I have filled that one out. Now this one. Oh, 1 second, guys. Let me hurry fix this. What I did here. Okay. So now this one, I would have 69 times 2. What will go in the first slot? What would come here?
60.
60. Very good. What will go in the other one?
9.
9. Very good. Now what is 60 times 2?
60.
60 times 2?
120.
120. And what is 9 times 2?
Miss,
Yes?
are you uploading this, Miss? Because we have another class.
Yes, miss.
You have another class?
But
Okay.
we don't have the link, miss.
Okay, so what I can do is, everybody has a class, I think, except for those that are packaged. Okay, what I will do is that you guys will have to leave, right? Because I don't want to get any of you in problems. You guys can leave, and then I will finish the recording. I will finish the other activities, and then I will upload everything in Google Classroom, and I will send it to the WhatsApp group for package. Yes.
Yes, Miss.
Yes,
Thank you.
miss.
Okay, guys.
Miss, thank you for your time.
No problem, guys.
Okay, miss.
You explain it clear, like the water, miss. Guys, Miss Katin get me really confused.
Okay, guys. Okay, you are free to leave. Get in your other class, and then I will finish the recording. Right?
Bye,
Yes,
miss.
thank you.
Thanks, bye, take care.
Bye.
Okay, Miss.
See
Bye.
you next weekend. Bye, miss.
Yes, miss, have a nice weekend.
Bye.
Bye.
Bye, Miss. Thanks for your time.
Okay,
Bye.
no problem.
Bye, miss.
Bye. Okay, Emmanuel, will you be staying?
Yes.
Okay, so then we can go ahead and finish this one because everybody else has a class. Okay, so here I have 69 times 2. If I want to break the 69, I'm going to put 60 and then 9. 60 times 2 gives me 120. And then 9 times 2, what does 9 times 2 give me? In this case, if I'm using my multiplication, 9 times 2 will give me 18. Then 120 plus 18, I always want to cross check my answer to see if it's correct, and I get 138, right? So that is that one. Moving on to the other one. I have 97 times 7. I want to break the 97. So I'm going to break it into 90 times 7 and also into 7 times 7. Right? And then now when I do my multiplication, I need to multiply. One moment. I need to multiply 90 by 7. All right? And then I'm going to multiply 7 by 7. So 90 times 7 gives me 360. And then 7 times 7 gives me 49. And then when I take 360 and I add 49, I get 679. And that is that one. Right? If I do the other one, I have 29 times 9. I want to break the 29, so I'm going to have 20. But 20 is going to be times the 9. And then I'm going to have 9 times 9. So now in the first one, I'm going to have 20 times 9. And 20 times 9 gives me 180. And then 9 times 9 gives me 81. And 180 plus 81 gives me 261. Right? Now, 17 times 8, and this is the last one. I want to break the 17 into 2. So I'm going to break it into 10. And then I'm going to times it by 8. And then the other part of the 17 is 7. And I'm going to times that by 8. So I broke the 17 into 7 and 10. And I'm going to multiply both of them by 8. So now 10 times 8 gives me 80. And then 7 times 8 gives me 56. And then now 56 plus 80 gives me 136. Right? And then we have finished that activity. Do you have any questions, Emmanuel?
No.
Okay. Okay, good. So let's continue to the other one. The other one is a matching. This is the last part, right? It's a matching. So now in this matching, let me put it as well so that I can type. One second. Okay, right here. I'm gonna start typing. Okay, so now I need to look for the associative property for addition, right? Now, when we talk about the associative property for addition, associative means that it has brackets and it has only addition. So if we look at all of this list right here, I need to look for the one that has brackets and has addition and represents the associative property. In this case, the only one that does that is B, because we have A plus B plus C is equal to A plus B plus C. So it has the brackets and it has the addition in different orders. So now if I take a look at number 2, the commutative property for addition. So now the commutative property for addition is basically I am adding two numbers and I can switch the places of those two numbers and they will give me the same thing. So I need to look for one of these rules that has two things that are being added, but they also can switch places and give me the same thing. And the only one that shows that is letter D right here. So number 2 is letter D. All right. Okay. Number 3, the additive identity operation of 0. Now, additive identity property of 0 is just a big name for something to mean the identity property for addition. The identity property for addition states that I am taking a number, I am adding it to 0, and it gives me back that same number. And if I take a look at all of these that are given here to me, the only one that shows a number being added to 0 is letter K. So that is number 3. Number 4, the existentive of additive inverses. Existentive of additive inverse. So now that is a big word to mean the addition, the inverse of addition, of a number under addition. So now when I talk about the inverse for addition, I need a positive and I need a negative of the same number so that when I add them, that gives me 0. So I need to look at everything that is given here to me, and the only one that shows that is letter F. Take a look at letter F. It says A plus negative a, and that is equal to negative a plus a. And when I solve that, it gives me 0. So letter F is number 4. Number 5, the associative property for multiplication. So this question talks about having brackets, having numbers in different order, and having only multiplication. And the only one that shows that here, if I'm looking at all of the rules one by one, is letter G. Now, why letter G? Because letter G has A times B in brackets, then times C, and that is the same thing as having the A outside and the B times the C inside. So everything is multiplication, it has brackets, and it has the numbers in different order. The commutative property of multiplication. So now when we want to talk about the commutative property of multiplication, this one refers to having two things that are being multiplied, right? I could have A and B, and then commutative means that the order does not matter. So then I can switch it and have B times A. And the only one that shows that here in the list is letter E, commutative property of multiplication, where I have A times B is equal to B times A. Commutative property of multiplication. The multiplicative in identity property of 1. That is just another fancy way of saying what is the identity property of multiplication. The identity property of multiplication states I have a number, I times it by 1, it gives me back that same number. And if I look at everything that is given here, all the laws from letter A to K, those laws, the only one that shows something like that, a number times 1 or 1 times a number, gives me back that same number, is letter A. Existence of multiplicative inverses. And again, another fancy way of saying the inverse of a number under multiplication. And this was a little tricky one that had, I give you a number and you had to give me the reciprocal. So I give you A and you had to give me 1 over A. I give you 3, you had to give me 1 over 3. And when I multiply them, the answer is 1. And the only one that shows that here in this list is letter I, where I have A times 1 over A is the same thing as 1 over A times A, and when I multiply it, it gives me 1. Now, the last three talk about the distributive property. The distributive property of multiplication over addition. The distributive property of multiplication over addition. So now what does that mean is that I have something on the outside, I'm going to times it by something in brackets, but what is in brackets has to be added. And if I take a look at everything that is left here for me, everything that is left here, the only one that shows that is letter H, which has A times open bracket B plus C is equal to A times B and A times C. The A on the outside is times the B, and then the and then the A is times the C. Sorry. So then you would have A times B plus A times C. Number 10. The same thing, distributive property, but instead of addition, now it's going to be subtraction. So I have something on the outside that I'm going to multiply by some things on the inside, which are subtraction, right? So then now the one that shows that is letter J. And if we take a look at letter J, you have A on the outside, and then you have B minus C on the inside. And then when I distribute that, I have A times B minus A times C. And that is showing distributive property over subtraction. The last one, distributive property to combine like terms, sorry. This is one that we did not cover, and you guys are not gonna cover until you go to second form. So this is like a sneak peek of something that you're gonna be doing in second form. But if I take a look at everything that I have done, the only one that is left is letter C. Now, why is that called distributive property, to combine like terms? If we take a look at letter C, I have A on the outside and I have A inside of the brackets. So now that means that when I times it by everything that is on the inside, I just want to get the two A's together. I don't want to have the two A's separated. So I am combining like terms. All right. So then this was the activities for this week. I will be posting them. Um, I will be posting the recordings in Google Classroom, and I will be sending them to the WhatsApp group, so that you guys can have it. But these are the activities. The first one is the matching of the vocabulary words, I would say. The second one is the 10 rules. I'm not gonna do the 10 rules. You guys have to make your own 10 rules. This one is on the one on filling in the blanks, distributive property. And then this last one was basically matching the names with its rule, right? So then this was the activities for this week, week 6. And I hope that this has helped you guys. I will be posting it in a little while, maybe like in 1 hour time. I will be posting it in Google Classroom, and I will be sending it in the WhatsApp group so that you guys can view it if you missed anything. All right, anybody has any questions? There are no questions, then you guys are free to leave. Have a great rest of the day and enjoy your weekend. All right? Your activities are due tomorrow. You guys can leave.